For the physical properties of alkanes and cycloalkanes, we are going to discuss from the perspective of physical state, boiling point, and solubility. The first physical properties we are going to discuss is physical state. So for straight chain alkanes at room temperature that is 25 degrees Celsius and atmospheric pressure 180 m, methane until butane, iaitu from C1 until C4 of alkane will exist in the form of gas, C5 until C17 in the form of liquid. Tapi in your syllabus kita hanya belajar sehingga decane sahaja, right? So pentane C5 until decane C10 of alkane will exist in the form of liquid, and for C18 until more, okay, above C18 lah maksudnya, the hydrocarbons or alkane will exist in the form of solids. So ini adalah basically the physical state for straight chain alkanes. And the second physical properties that we are going to discuss is boiling point. So the boiling point of alkane can be discussed into these three different categories, iaitu boiling point of straight chain, boiling point of branch chain, and boiling point of cycloalkane. So the basic idea adalah straight chain alkanes will have higher boiling points. Okay, kerana apabila molar mass or molecular size increases, boiling point will be increases. And for the branch alkanes, the more branching of the alkanes chain, the lower the boiling point. And basically, we can see that as the molar mass increases, boiling point will be increases. So from these 2 points, can you relate with what you have learned in the previous semester 1? If you still remember, you have learned ada 3 factors yang kita akan gunakan untuk determine the variation of boiling points of certain molecule. Okay, iaitu sama ada nak menggunakan factor molecular size, molecular shape, dan juga molecular polarity. So we are going to apply the concept in discussing boiling point of alkanes. So now we are going to discuss the boiling point of straight chain alkanes. Straight chain maksudnya alkane yang tiada cabang lah, tiada branching. Okay, so ini example untuk straight chain alkanes. Okay, alkanes yang mempunyai parent chain garis lurus sahaja. Okay, parent chain rantai lurus. So basically, boiling point of straight chain alkane increases with relative molecular mass. So as molecular mass increases, the size of the molecule increases, the surface area will be increases, and of course the intermolecular forces of attraction will be increases. Okay, so the intermolecular forces of attraction kita boleh panggil juga sebagai van der Waals forces, or to be specific, it is London dispersion forces. Kerana apa? Kerana alkane adalah non-polar molecule. So more energy is required to overcome the intermolecular forces of attraction between molecules as the molar mass become larger. So hence this will result in the increase in the boiling point. Okay, so apabila molar mass increases, the boiling point will be increases. So di sini you boleh nampak bahawa kita telah mengaplikasikan faktor molecular size. So this is just to show you the difference between surface area between this alkane iaitu ethane dan juga butane. So daripada ethane to butane, we can see that the number of carbon atom increases. So definitely apabila number of carbon atom decreases, we can say that the molecular mass and molecular size will be increases. So, apabila ethane molecule mendekati another ethane molecule yang lain, maka this will be the surface area between ethane. Alright, so you can see that here are the surface area, okay, which is smaller than you can see daripada this butane and butane surface area. So basically, apabila surface area is small, the molecular weight also small, boiling point will be lower. And as we have a bigger surface area ataupun contact area di sini, Okay, and molar mass also increases, so the boiling point will be increases. So the greater the surface area, the greater the intermolecular forces of attraction, the greater the energy needed to overcome the forces between these two molecules, so hence boiling point will be increases. You can also observe the variation of the boiling point of straight chain alkanes in this graph. Okay, so here is the number of carbon atoms and this is the value of the boiling point. So we can see that when the number of carbon atom increases, the boiling point also will be increases. So for straight chain alkane, as molar mass increases, surface area will be increases, the strength of van der Waals forces will be increases, and the boiling point will be increases. So di sini kita akan mengaplikasikan factor molecular size in explaining the variation of the boiling point for straight chain alkanes, iaitu alkane yang tidak mempunyai branching ataupun garis lurus sahaja. And now we are going to discuss the boiling point of branch alkanes. Okay, alkanes yang ada cabang. So basically for branch alkanes, branching will make a molecule more compact. Okay, lagi banyak branching, okay, lagi banyak branching, lagi compact the molecule or lagi spherical the molecule of alkane. So apabila lagi spherical molecule of that alkane, surface area will be decreases. So hence the strength of the London dispersion forces, or you may write as van der Waals forces, will be decreases or weaker, and hence the boiling point will be lower or decreases. So this example is to show you the difference or variation of the boiling point between straight and branch alkanes. Okay, so this is 2,2-dimethylpropane dan ini adalah pentane. So if you can see from the number of carbon and hydrogen of these two molecule, ini adalah C5H12 dan ini juga adalah C5H12. So sekiranya they are having same molecular formula, so apa yang kita panggil kepada dia, kita gelarkan sebagai apa? Okay, kita gelarkan ia sebagai isomer. Okay, so ini adalah isomeric alkane. Alright. So daripada this straight chain, bila awak buat chain isomerism, so you might get this 2,2-dimethylpropane. And as you can see, for 2,2-dimethylpropane, the boiling point is 10 degrees Celsius and pentane has 36 degrees Celsius. Okay, so apakah sebabnya? Definitely you can see that pentane has long and linear molecules. Okay, sementara 2,2-dimethylpropane has two branchings. Okay, on the structure lah. Okay, so di sini apabila kita ada long and linear molecule, iaitu the one yang having no branching, the greater the surface area between this one molecule and the other same molecule, and the van der Waals forces between the molecules di sini akan menjadi stronger. Okay, sebab contact area-nya adalah besar. Sementara untuk 2,2-dimethylpropane yang mempunyai dua branching di sini, the shape is tend to be more spherical. Okay, kenapa more spherical? Sebab ada banyak branching. So you may mention berapa banyak branching yang this molecule ada. Alright, so the spherical the molecule, the less the surface area between one molecule dengan the other molecule, and hence weaker van der Waals forces, okay, between the molecule. So from the example just now, we can relate with isomeric alkane. Okay, we can relate with the concept of isomeric alkanes. So basically, isomeric alkanes will have different boiling points due to branching. So as the branching increases, the more spherical the molecule, the less the surface area, and the boiling point will be decreases. So here are the examples of isomer of C5H12. So this is pentane with 314 Kelvin. Okay, so 2-methylbutane ada satu branching, okay, with boiling point 313.56 Kelvin, and 2,2-dimethylpropane has two branching, okay, with boiling point 310.77 Kelvin. So all these molecule adalah isomeric to each other. Okay, isomer apa? Isomer of C5H12. Alright. So di sini in discussing the isomeric alkanes, we can use factor molecular shape. Alright. So the greater the number of branching, okay, the lower the boiling point, because the shape is tend to be more spherical. So the less surface area, okay, of this molecule, okay, yang ni akan ada the greater surface area. So that will affect the boiling point between isomeric alkanes. And now we are going to discuss the boiling point of cycloalkanes. The boiling point of cycloalkanes are 10 to 15 degrees Celsius higher than the corresponding straight chain alkanes. This is due to more rigid and symmetric cyclic system. So di sini kalau awak tengok, kalau kita compare di antara butane dengan cyclobutane. So both of these molecule having 4 carbon atoms. Okay, butane has negative 0.5 degrees Celsius and cyclobutane has 13 degrees Celsius. So definitely and obviously kita boleh nampak bahawa butane ini has lower boiling point than the cyclobutane. Okay, so in other example as well, okay, untuk bilangan karbon yang sama di sini, we can see the same trend. Okay, the straight chain alkane, bila kita compare dengan pasangan dia, pasangan cyclobutane yang mempunyai bilangan karbon yang sama, so straight chain alkane akan mempunyai lower boiling point than the cycloalkane. Okay, so kenapa? Reasonnya adalah disebabkan oleh rigid and symmetric cyclic system, ataupun dengan kadar kefahaman kita, okay, ataupun dengan cara yang mudah untuk you faham, kita bayangkan seolah-olah okay, butane adalah straight chain macam ini. Kalau cyclobutane, kita akan ada bonding like this. Alright, so apabila kita approach another molecule of butane dengan butane, maka ini sahaja dia punya surface area. Okay, sementara bila kita approach another molecule of cyclobutane dengan another molecule of cyclobutane, we can see that seolah-olah seperti surface area itu besar. Okay, surface area di sini adalah kecil. So mungkin dengan cara ini, okay, boleh membuatkan awak lebih fahamlah kenapa boiling point untuk cycloalkane ini lebih tinggi daripada alkane yang mempunyai karbon yang sama. Okay, so mungkin disebabkan oleh its surface area yang besar lah. Okay, untuk this cyclic compound. So mungkin itu cara mudah yang boleh digunakan untuk you faham kenapa cycloalkane ini akan having greater boiling point than the straight chain alkane. Okay, tapi reason dia yang utama adalah due to more rigid and symmetric cyclic system. The third physical properties will be solubility. So alkenes are less dense than water and described as hydrophobic. Okay, hydrophobic means hate water, doesn't like water. And alkanes and cycloalkanes are almost totally insoluble in water and polar solvents. Okay, kenapa begini? Kenapa alkane dan cycloalkane akan insoluble, tidak larut dalam water dan juga polar solvent? Definitely because alkane dan cycloalkane itself, they are non-polar molecule. Okay, you have to remember, konsep untuk solubility adalah like akan soluble ataupun dissolve in like. Okay, like, dissolve or soluble in like. Kalau kita ada non-polar, maka non-polar akan soluble ataupun dissolve in non-polar solution. Kalau kita ada polar solution or polar molecule, dia akan soluble or dissolve in polar molecule or solution as well. Okay, so itu maksudnya like will soluble or dissolve in like. So di sini apabila alkanes and cycloalkanes adalah non-polar molecule, maka non-polar definitely takkan larut di dalam polar solvent. Water juga adalah polar solvent. Okay, so that's why bila you campurkan alkane dan juga cycloalkane, you akan nampak this kind of observation. Okay, so di sini kita akan ada alkane on top layer dan juga water at the bottom layer. Okay, so density of alkane adalah kurang daripada water. So that's why alkane akan float, okay, di atas water, and you can see ada satu boundary di sini. So this boundary showing that alkane is insoluble in water ataupun immiscible in water. Okay, so ketelarutan antara alkane dan water ni kita boleh kata dia tidak larut. Okay, so and the main reason behind that of course adalah disebabkan oleh the alkane dan juga cycloalkane unable to form hydrogen bonding with water. So basically, sekiranya kita nak bercakap tentang solubility of something in water, kita akan kaitkan dengan ability to form hydrogen bonding with water. So di sini definitely alkane and cycloalkane are unable to form hydrogen bonding with water. So ini yang menyebabkan alkane is immiscible ataupun insoluble in water. So, sekiranya alkane dan juga cycloalkane ini is insoluble in water, so dalam solution or solvent manakah mereka akan larut? So the answer is alkanes and cycloalkanes are soluble in one another. Kenapa macam ni? Sebab alkane adalah non-polar. Okay. Cycloalkane juga adalah non-polar. So like akan soluble ataupun dissolve in like. And also alkane and cycloalkane are soluble in non-polar solvent. And these are the examples of non-polar solvent yang kita akan regularly use together with the alkanes, iaitu benzene, carbon tetrachloride, okay, chloroform, dimethyl ether dan juga other hydrocarbons. So apabila alkane and cycloalkane are soluble in this solvent, maka you akan dapat satu homogeneous solution sahaja. Okay, dalam slide yang kita baru je lihat tadi, yang itu kita merujuk kepada heterogeneous solution. Okay, kerana kita ada two distinct layers, okay, two different layers. And for this kind of solution, kita panggil sebagai homogeneous solution. And this is showing that the alkanes and cycloalkanes adalah soluble in the given solvent. Okay, and the solvent could be any one of these. The natural sources of alkanes. We can extract alkanes from natural gas dan juga daripada oil. So natural gas contains primarily methane and ethane with some propane and butane, and oil is a mixture of liquid alkanes and other hydrocarbons. And this is actually what you have learned in the previous level. Okay, so kita just recall sahaja. So these are the gases yang akan di-extract keluar daripada petroleum distillation, and these gases form akan mengandungi C1 until C4 hydrocarbons, alkanes, okay, dan digunakan sebagai fuels dan juga reactants to make plastics. Dan untuk C5 until C12 hydrocarbons, okay, di-extract dalam bentuk gasoline dan digunakan sebagai motor fuels dan juga industrial solvents. Okay, and some other hydrocarbons ini akan di-extract keluar, okay, dalam bentuk-bentuk ini. In discussing the physical properties of alkene, we are going to focus on the variation of the boiling point and melting point. And of course, this is not something new for you because you have learned the variation of boiling point and melting point of cis in chapter 4. So basically, untuk discuss physical properties of alkene in the form of melting dan juga boiling point ini, kita akan fokus on cis and trans alkene sahaja. Okay, so boiling point of cis is higher than the boiling point of trans. Okay, this is due to the polarity of cis compared to the trans. And for the melting point, trans will has higher melting point than cis. Okay, this is because trans structure is arranged closely and densely packed together. Okay, so sekiranya awak dah lupa, please revise what we have learned in chapter 4. Okay, boiling point of alkene dan juga melting point of alkene. So with that, we have done with physical properties of alkane and alkene.